All right, in this video we're going to take a look at some basic quality control symbols. This is not going to be an exhaustive look of all the symbols, but it'll give you an idea. And the importance of this is you're going to see this in your text, you're going to see this in equations. In fact, it's probably going to be incorporated into your language as you learn more about the discipline. In quality control, just like math, X represents a sample value. So if I pull something out of a production process and measure a feature of it, maybe I pull a shaft out that I'm producing and I measure the diameter of it, the measure of that diameter would be a sample. Now what you're going to see oftentimes in equations, and we'll look at one later on, would be something like this: X sub 1, X sub 2. And all that means is, here I have two samples. This was the first one I pulled, this was the second one I pulled. Usually when we pull samples within a process, they're consecutively pulled. So if, for example, if I was going to pull 5 samples every hour, I would simply pull all of them, 1, 2, 3, 4, 5, and that would become sample X1, X2, X3. You get the idea. The bar over the X, the bar indicates average. And what we're looking here is, if I have 5 of these, if I then add them together, get a total or sum of them, divide by the number of samples I have, 5, I then have the average one of that group or that set. This is referred to as X bar, and that will become part of your language. You'll be talking about the X bar value. In reality, what you're talking about is an average value, or if you want to get a little more technical, we're talking about the mean, what's referred to as the mean. Average and mean being the same thing. The double bar, X with 2 bars over it. Fundamentally, this is simply an average of averages. So if I were to collect 5 samples each hour over an 8-hour day and average those, then if at the end of the day I were to average those 8 averages, that would be my double bar, an average of the averages. R for the range. When I have a set of samples, what I'm going to do to calculate the range, and we're talking about variation here, if you remember, we've said variation is probably one of the most predominant issues we watch in quality. What I've done in my group of samples is I've taken the largest sample value, subtracted the smallest sample value, and that gives me R, the range, or what's referred to as the range of the variation. So in essence, I know how much variation spans that set of samples. Then obviously, the R bar value would be an average of those ranges. Lowercase n indicates a number of samples. Now this, you have to be careful about this. This could be a number of samples in a individual set of 5, or if I pulled 100 but that wasn't the total group, it could represent that whole subgroup. The uppercase N indicates the number of samples in a population. All right? Now, what we want to do is make sure you understand the distinction between the lowercase n and the uppercase n. When I'm talking about a lowercase n in a formula, that means I don't have all the items, I simply have a group of them that have been picked. If I see an uppercase n, that means then I need to have values for the entire group of values, the entire population. The lowercase k represents subgroups, how many subgroups. So in essence, if I go back to my example of picking 5 samples each hour, 5 consecutive samples each hour, at the end of an 8-hour day, my k value would be 8 because I would have 8 subgroups, one selected each hour. Now this is the uppercase sigma character, refers to in equations as summation. Basically says sum up the following, or what's the sum of the following values. Lowercase sigma is the symbol we use for standard deviation. Standard deviation, which we'll talk about a lot more further on, is simply a number that reflects how the variation of a group of samples spreads out from the average or the mean of those samples. What we often refer to as the square root symbol, or technically correct, a radical. The radical symbol, radical means root. So we're asking for like a square root. If you see it just like this, it's asking for the square root. Or we can ask for the nth root. For example, if I want the square root of the value of 5, basically what they're saying is what's the root value, or what number multiplied by itself would result in 25, and that would be 5. 5 times 5 is 25. Make it so you can read it. here what it's asking is the nth root, or what is the third root of 347, or in other words, what value times itself 3 times would result in 343, and that would be 7. 7 times 7 is 49. 49 times 7 is 343. So you may see a root something other than square. If there's no number here, we're talking about just the square root, the number by itself. If there is a value here, then that becomes how many times the number is used as a factor in the equation. X to the nth, then again, this means to raise a number to a given power. What we've got here is, if we think about, let's just go back with these numbers here. If I take my 5 squared, okay, 5 is the x value, n is the power. In essence, this is referred to as the exponent. This is referred to as a factor, because all powers are a multiplication process. So what we're saying here is multiply this number by itself 2 times. So in essence, we're saying, what is 5 times 5? In other words, the exponent tells me how many times I use this value as a factor. So this would be 5 times 5, and obviously would be 25. If I had 7 to the third, then that would be 7 times 7 times 7. Okay? So in essence, the exponent tells you how many times the value, or x, is used as a factor in a multiplication process. That is the bulk of the symbols that you'll see in respect to equations. I've got a couple examples here, actually 3, and let's just take a look at that. So obviously here what we're asking for is an average x bar. Now, it's a fraction that we have to solve. And notice they're saying, okay, x sub 1 plus x sub 2 plus x sub 3 on down to whatever you've got. If the sample size is 5, 6, 7, 10, you simply are going to total all the samples. And then n is the number of samples you've got. So when you total that and divide by n, you will then have the average, or the x bar value. Remember, you must solve the numerator portion of the fraction before you can solve the entire fraction. So this has to be done first, so you can then divide by that. This is a calculation that comes from control limits, which we'll look at much more down the road. But the C value represents defects in a part. And obviously, even with what little we've covered, you should be able to understand right now that we're looking for the average number of defects. C bar would be an average. So what we're saying here is, instead of having C1, C2, C3, we're simply saying sum up all of the defects you have. This is a count. How many do you have? Did I count 10, 20, 30 defects? And then divide that by the number of subgroups those represented. How did I pick them up? So here you have a summation character used. Again, this has to be calculated before you divide by the number of subgroups you have, and that would then give you your average defects. This is a calculation a little more complex for the upper control limit of defectives. Where defect is a part, we talked just a minute, defect is a part that has a blemish on it, but it doesn't mean that the part is not usable. A defective part is a part that we're not going to be able to use at all. So this is looking at defectives. Control limits, again, we'll talk about that, has to do with variation. Again, we'll hit that later on. But this calculation here says, all right, the average percentage of defectives has to be added to 3, which then is multiplied by the solution to this radical. So let's just take a look at this equation and see what we would do. Because of the rules of math, we're going to solve the numerator portion of the fraction first. The parentheses represent a subgroup that must be calculated first. So we're going to take the value of 1 and we're going to reduce it by whatever that p-bar value is that was calculated earlier. So in essence, this is going to be the first calculation that's done. Once we've done that, we're going to multiply it by the p-bar. And you'll remember from the math review that we did, even though there's not an operator symbol here, it implies multiplication. Whatever is the total, or whatever the result of this subgroup is, gets multiplied by that value. So then second, we're going to do the multiplication. And then third, once that numerator is completely solved, we will divide it by the value of n. If you recall, n is the number of samples in the group. That solves the fraction within the radical, and the radical means what? Going back over here, there's no number in here, so therefore we take the square of that. So this would wind up being the fourth part of the solution. We then come back and multiply it by 3 and add it to whatever the p-bar value is. That's a little more complex, but what I wanted you to see is here's how you'll see a lot of these within an equation. Here you've got a reference to an average. Here you have a reference to a number and set. Here you have the radical indicating you're going to take the square root. Up here, the summation symbol, the carry system symbol. Everything that we do will have an equation for it, and in most cases, those equations will have primarily these symbols within them.